Welcome to Internet Quality Academy. The channel is for the quality control engineer, civil engineer, and the site engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. Today also, I'm going to discuss about a very important topics of the quality control. That is fishbone analysis. What is fishbone analysis? How to perform the fishbone analysis, and what is the major component, and how to use in your projects. I will give a practical example. So stay tuned until the end to get the full information about the fishbone analysis. And if you are new on my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So without wasting time, let's jump into the subject, that is fishbone analysis. Now, what is fishbone analysis? Before that, we need to know that there are 7 QC tools in order to determine the root cause analysis, probable reason for the defects, and find out the best action plans to eliminate the defects from the process so that the end product can meet the customer requirement or it can exceed the customer requirement. So that 7 QC tools, one of the major tools is that fishbone analysis. Sometimes it is called Ishikawa diagram. Also, it is called cause and effect diagram. So if you want to know about the 7 QC tools, I have made a detailed video. Link is there or in the description. Please check. It is my recommendation. Please check that one and then come to this video to know about the fishbone analysis. So first, what is fishbone analysis that we need to know? The fishbone analysis, also known as the Ishikawa diagram that I already told, or the cause and effect diagram. So it is a cause and effect diagram. It is a fishbone analysis. Why it is called fishbone analysis? Because it's whenever we are performing this analysis, it looks like a fish bone. See, here is a main skeleton, there is a sub bones, and there is a branches. So it is looks like a bone of a fish. That is why it is called the fishbone analysis. And why it is Ishikawa diagram? Because it was invented by the professor of Ishikawa from Japan. That is why it is called the Ishikawa diagram. But what is that? Diagram is a powerful problem solving tool. That means it is a tool to find out the root cause. That is to identify the root cause of an issue. So there is any issue in your projects or your process, that you can perform this cause and effect diagram and you can find out the issues. This method visually maps out potential causes and organize them into a categories resembling a fish skeleton. So it is a visual representation. Whenever you're making this one, everything will be in front of your eyes: the problem, the probable cause, probable sub cause, and then the action plan or the whatever the remedial measure. So this is the fishbone analysis, and I will give an example from the construction. You will get full information. And sometimes it is called 5M plus 1U or the 6M method, that I will discuss later why it is called. So this is the fishbone analysis. Now next part is, what is the brief history when it was invented? The fishbone diagram was developed by Dr. Ishikawa in 1960s, and a Japanese quality control expert and a professor at the University of Tokyo. So he was invented this fishbone diagram. It was initially used to improve the quality of products in manufacturing industry, but now it is widely used throughout the world for any sector or any kind of organization. So it was first invented in the Japan by the Professor Ishikawa in the Tokyo University, and that is why it's called Ishikawa diagram also, as well as cause and effect diagram, because it is always focusing effect, that the problem and the probable cause, and the fishbone analysis, because whenever we are performing, it looks like a fish skeleton. So this is the little bit of history about the fishbone analysis. Now the next, what is the main component of fishbone analysis that we want to know? Because whenever we are performing fishbone analysis, we need to know what is the structure and how to do that. There is a 3 categories of component. One is the effect or the head, one is the major categories of the bones, and the subcauses or the small bones. So let's look at the picture. See, here is the problem. Suppose you are doing the concrete and you are getting cracks in the concrete. So cracks in the concrete will be the main problem or the main bones, and these sub bones will be the bones will be the probable causes. So these will be the probable causes, and under the each and every probable causes there will be the small bone or the sub causes. So these are the structure to find out the root cause. So what is the effect, the problem or issue that needs to solve is written in the head of the diagram. So here, then major categories of bone, that is these all the major categories of bones. Main causes are organized into broad categories. Each of is connected to the spine of the diagram. So it's all are connected to the main problem. So what will be the major categories? Major categories, there are 6 parameters we need to evaluate. So it's the 6 parameter is manpower, that is a people, method, that is a process, materials, machineries, environment, and the measurement. So here you can see there are the 6 parameters or the 6 main subclause or the causes that can determine the root cause of any problem arises in the manufacturing or the process. So first is method or the manpower. It is a human related cause like lack of skill or improper supervision. That can be one reason for developing the cracks. Then methods, issues related to the procedure or the system in place. So whatever the system we are following, maybe a problem with the system. So we need to find out, is there any problem in the system or not? Then material, whatever the material we are using, there could be poor quality of material which leads to the cracks or leads to the problem. Then machineries, what are the machineries we are using? Then an environment, external factors such as weather, site condition, etc. Then measurement, whenever we are measuring that one, there may be error. So on that basis also there can be a problem or can be a defect can find out. So these are the major categories or the major sub clause, that is manpower, methods, materials, machineries, environment, measurement. Here you can see there are 5M and 1E. That is why it is called 5M plus 1E method. Sometimes the people are called this environment is the mother nature. That is why it's become again 6M. That is why it is called the 6M method also. So the fishbone analysis, cause and effect diagrams, Ishikawa diagram, 5M plus 1E or the 6M, these are all the same, only the terminology is the different. So these are the major sub categories, and then sub clauses. These are the detailed potential reason under each category that might contribute to the problem. So these are the major methods, materials, manpower, and here in manpower there is a sub clause. Maybe the training is not adequate, they are not inexperienced, they are not qualified. So these are the sub clause. So like this way, we have to first find out the problem, then whatever the 6 parameters, and under every 6 parameters we need to find out the what is the possible reason, and on that sheet we can find out the exact reason. It's a brainstorming or the root cause analysis. So these are the major component of fishbone analysis or the Ishikawa diagram. Next, why it is important? Because everything whatever we are learning, that we need to know why this thing is important for us. That the fishbone analysis helps identify the root cause of a problem rather than just addressing the symptoms. So what is our motto or what is our target? To find out the root cause so that the reoccurrence of the problem should not happen. Or suppose we are getting cracks, we are feeling the cracks, again we are getting the cracks, we are again feeling the cracks. That is, we are just taking the corrective action. We are not taking any preventive action to stop the reoccurrence. So here it is important to find out the root cause. What the we don't want to address the symptom or the problem. We want to find out the cause of the problem, and we need to go to the root and eliminate that problem from the process. So first is organizing, brainstorming ideas efficiently, then identify relationships between cause and their effects, then pinpoint the true root cause of a problem leading to more effective solutions, prevent reoccurring by addressing root causes, improving the quality of work. So that is why this fishbone analysis is very important, because it is going to the root, up to the root level, and find out why the defects has come. And when the root cause is find out, we can immediately find out the solution. It's just like a doctor as finding out why we are become sick or we become ill. They are going to the depth and find out the root cause, and they give the treatment. We will become free and we become healthy. So this also for the projects or the for or anything, we need to find out the root cause and give the identical solution or the proper solution, so that we can get the product as per the requirement. That is why it is important. Next is how to perform fishbone analysis that already I discussed, that first we need to define the problem, then identify main categories, brainstorm subclauses under each categories of possible subclauses. For instance, under materials, you might list poor quality cement, improper mix ratio, blah, 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 this. Then analyzing and identify root cause, and then develop an action plan. So these are the way you can perform fishbone analysis, and you can find out easily what is the root cause and possible solution. So these are the thing about the root cause fishbone analysis. Now we will check with the example from the construction. Then you can find out why this is happening. So here is a problem we need to address. The problem is that we are getting cracks in the concrete. So now we need to find out why this crack is developing in our concrete. So we need to perform what is the fishbone analysis. So here is the main problem, that is the effect, that is cracks in concrete. Now what is my sub clauses? Methods, materials, manpower, measurement, mother nature, and the machineries. Now under each problems, we need to causes, we need to brainstorm, and we need to find out the sub clause. So under manpower, what we can say, that is inexperienced worker, lack of proper training, or they are not medically fit, whatever this reason, we have to do the brainstorming, and then we have to find out the root cause. So under manpower category, we can say it is inexperienced worker, lack of proper training, etc. Then coming to the material part. Material part, we can say low quality of aggregates, improper water cement ratio that can lead to the concrete cracks. Then other things also, you do the brainstorming and find out. Then the method is coming. What is the method? That's the improper curing method, inconsistent mixing, improper vibration, whatever. So there are a lot of subclause we can find out under this. And then again, improper curing, we can find out the water quality. That means improper curing is not adequate. That means if it is required 4 times in a day, maybe they are giving 2 times. So in under subcategory also, we can break down under subcat clause, so that we can go exactly the root cause why it is happening. Then machineries. In machineries, we can say that the faulty concrete mixer, batching plan not calibrated, that is why it is the erroneous mixing. Then mother nature, you can say whatever this rain, wind, that can also an effect on the cracks in the concrete. And then measurement, then inaccurate measurement tools, and the improper mixing time. So in the measurement also, suppose we need mixing time 2 minutes, but it actually is happening in 1 minute. So that means improper mix is there. That is why the cracks can develop. So in this way, we need to brainstorm the methods, material, manpower, measurement, mother nature, and machineries. Now each and every subclause, we need to check whether there is an inadequacy or not. If we find out that experienced worker are not experienced, that we need to find out the inexperienced worker, or we need to do the proper training to them. So in that way, we need to find out that which categories or under which categories there is a deficiency, and because of that we are getting cracks in the concrete. So then we need to develop an action plan. Suppose for the, above this clause, we find out the root cause, identify that inconsistent mix ratio and improper curing. So these are, we can find out, these are the root cause. Now solution, like better training for the workers of mixing procedures and improved protection of concrete during curing could be implemented. So once we find out the root cause, then immediately we can find out, or we can provide the solution for the root cause or for the remedial effect. So this is all about the fishbone analysis or the cause and effect diagram. I hope you find it useful, and if you find it useful, kindly subscribe my channel and hit the bell icon, so that whenever I upload a new video, you will get immediate notification. And I'm waiting for your valuable comments, so that from your valuable comment, everybody will be benefited. And if you want to know anything more about quality control and construction, please let me know. I will come with more content like this. And thank you once again for watching me.